Hello everybody. So in this video, we are going to discuss about Sophie Germain's identity. It is an important identity from a mathematics Olympiad point of view. So let's start with it. So you see, basically Sophie Germain's identity is the factorization of this type of expression, x raised to the power 4 plus 4y raised to the power 4. So let's do it first. Let us prove it. So x raised to the power 4 plus 4y raised to the power 4. So basically you see this can be written like this, x square the whole square plus, you see this thing is nothing but 2y square the whole square, right? Now you know this identity you must have studied since childhood. You see a square plus b square can be written like this, a plus b the whole square minus 2ab, right? You can obviously write it and you can prove it as well. Now you see over here, if I consider x square to be a and 2y square to be b, isn't it a square plus b square form? So it will be a plus b the whole square. So x square plus 2y square the whole square minus 2ab. So minus 2 into x square into 2y square. Now what is this, guys, after this? So this is x square plus 2y square the whole square minus, you see this thing can be written 2xy the whole square. You can easily see this because this is 4x square y square, so you can write it like this. Now can't we use a square minus b square identity now? If I consider x square plus 2y square to be a and 2xy to be b. So a square minus b square is a plus b into a minus b. So it will be x square plus 2y square plus 2xy multiplied by x square plus 2y square minus 2xy. So you see, this is the Sophie Germain's identity. It means that x raised to the power 4 plus 4y raised to the power 4 can be written like this. Now you see, this can be further manipulated to make it look more easy. See this. This is x square, and if I take y square from it and then 2xy, can't you say that it will be x plus y the whole square? But you see, one y square is already there. The same we can do over here. You see x square and 1y square we can take from here and minus 2xy. So you can write it like this, x minus y the whole square, and then from this 1y square is already left. So you see, this is more, easy and more usable form of the Sophie Germain's identity. That x raised to the power 4 plus y, 4y raised to the power 4 is x plus y the whole square plus y square into x minus y the whole square plus y square. So this is very useful and very important from, many Olympiad basically. So let's do some questions on the basis of it. So for example, you see this question, find the largest prime divisor of this number. Now if you see this question, you will be like, oh my god, how will I know what is the largest prime divisor? So basically, in order to know the prime divisor or any factor, something like that, you need to do the factorization of it. So you'll go for prime factorization. But you see, if you will find 25 square and then this square and then add and you'll do prime factorization, it will just waste your time. So instead of that, we can use the Sophie Germain's identity in this. So you see how we can do. This is 25 square, which is basically 5 square the whole square, right? And this is 72. 72 is 2 into 36 and then the whole square. Just for you to understand, I'm writing these, right? So this is 5 raised to the power 4. And this can be written 2 square into 36 square. I'm just writing these things in detail. I know that if you're preparing for an Olympiad, you know these things, obviously. But still, I'm explaining this in detail. So this is 5 raised to the power 4 plus 4. And you see, what is 36 square? 36 is 6 square. And then the whole square is already there. So this is 6 raised to the power 4. Aren't you able to see this is in the form of the Sophie Germain's identity? Can't you think that it is x raised to the power 4 plus 4 into y raised to the power 4 form? Can't we use this form of the Sophie Germain's identity easily? So it is what, guys? It is x plus y the whole square, which is 5 plus 6 the whole square, plus y square, that is 6 square, and then in the other bracket it will be x minus y the whole square, and then you see plus y square, which is 6 square. You see, we have easily factorized it. This is basically 11 square and this is 6 square. 11 square is 121, 6 square is 36. So what is that, guys? 121 and 6 6 are 36. So that is 7, 5 and 1. So that is basically 157. And what about this? This is basically minus 1 square, which is 1 only. 1 plus 36 is what? 37. So you see, we have easily factorized it. And if you will check, this is a prime number, this is also a prime number. So they are asking the largest prime divisor. So the answer will be easily 157. You can obviously check for any calculation mistakes. You see 121 plus 36, that is 157, it's correct. I hope it's clear. You see, you can easily do it. Now suppose sometimes they will give you a question like this. Again, it's like, oh my God, so big, or how will I do it? So basically, I'll write it properly. They are asking you to find square root of n minus 1. If it is given that n is equal to 99 raised to the power 4 plus 4 into 98 raised to the power 4 divided by 98 square plus 197 square. So you see, obviously, if you will just calculate these, you will never get the answer. In 200 years, you'll get the answer, right? So obviously, you don't need to do any expansion over here. Let me check if I have written it correctly. Yes. So this is a direct question on the Sophie Germain's identity. You see, it's a direct question. X raised to the power 4 plus 4 into y raised to the power 4. That's a direct question. So what is that, guys? It is basically x plus y the whole square, x plus y the whole square, plus y square. Y square is what over here, guys? 98 square, right? And then in the other bracket, it will be x minus y the whole square, x minus y the whole square, and then plus y square once again, that is 98 square. And then in the denominator, you have been given with this 98 square plus 197 square. Now you can see this. Basically, if you add them up, 9 plus 8 is 7, 9 plus 9 is 16 plus 1, 17. 18 plus 1, 19. So 99 plus 98 is basically 197. So this is 197 square and this is 98 square. So this thing and this thing is exactly the same. So this is basically 1 square is 1 plus 98 square. I hope you understood that. So after simplifying n, we are getting this only. We are left with nothing. So we want to find the square root of this thing. It's a direct question now. You see, this is square root of n is nothing but 1 plus 98 square, and minus 1 is already there. It will be cancelled out. So square root of 98 square, that will be 98 only. It's the answer. So you see, it's a very direct question. If you just see that, and if you know the Sophie Germain's identity, you can directly do it. Let's move on to the next one. So sometimes you can find remainder as well using Sophie Germain's identity. Obviously, we are not going into that discussion in this video. There are various ways of, finding remainder in a question. Not every time, but many times. In this question as well, there are various ways of it. But I can explain this question using the Sophie Germain's identity. You see, it will be very easy if you understand that thing. See this. So that will happen if you are able to identify that thing. See, if I see this thing basically, I can understand it like this. See, 1 plus, suppose, like this. and you see 201 will be left as it is. Why I'm doing it? Can we think of factorizing this thing using Sophie Germain's identity? Can we think of factorizing this thing, guys? So this is basically what you can just write it, you see, like this. And then this thing, if I take, it is 2 square into 2 raised to the power 200. I hope you understand that. So this is basically 1 raised to the power 4 plus 4 into, if you write it like this, 2 raised to the power 50 raised to the power 4. Are you able to observe that? Using the Sophie Germain's identity now, you see this is x over here and this is y over here. So can't we factorize it using the first form of the Sophie Germain's identity basically? Because the second form, if you will use, that will not be useful. You see, this will not be useful. But the first form will work in it. Now that will work with practice, obviously. So you see, this is nothing but what it was. It was 1 square x square plus 2y square. So 2 into this thing y square plus 2xy. So 2 into 1 into 2 raised to the power 50. Right? This is the first thing. And then the second thing is x square plus 2y square. So 2 into 2 raised to the power 50 square over here and minus 2xy. So minus 2 into 1 into 2 raised to the power 50. I hope you understand that in place of x, we are using 1 and in place of y, we are using 2 raised to the power 50. So this is nothing but, if you simplify, it is basically 1 plus, this is 2 raised to the power 100 into 2. So it will be 2 raised to the power 101 plus. This is 2 raised to the power 50 into 2 raised to the power 1. So it is 2 raised to the power 51. Now over here as well, you are getting 1, and then you see this thing is like this only, 2 raised to the power 101 minus this thing is like this only, 2 raised to the power 51. So basically, I hope you understand that this situation, this thing is equal to this. If you divide this whole thing by this thing, you see 1 plus 2 raised to the power 101 plus 2 raised to the power 51. What does it mean? I mean, this thing, this part is actually exactly divisible by this. This part is exactly divisible by this. So what will be the remainder left? Tell me. If you divide this whole thing by this whole thing, what will be the remainder left? This part is exactly divisible by this thing. So the remainder will be 201 only, because that is not divisible. So the answer is 201. So you see, we have done 3 questions on the basis of the Sophie Germain's identity, and that is very important. I hope you are getting what I am discussing over here. So on the basis of the same thing, can you try doing this one? So you see, this is looking a bit complex, but basically it can be done using the Sophie Germain's identity only, right? I mean, first thing I can explain if you want. For example, the first one, it is 10 raised to the power 4 plus 324. You can obviously simplify it in the form of Sophie Germain's identity. You see this? This is basically, you can write it 4 into, this is what? 81. So that is 10 raised to the power 4 plus 4 into 81 is what, guys? 3 raised to the power 4. So you can use the Sophie Germain's identity over here. So in the same manner, you can use the Sophie Germain's identity in all of those things, and things will be cancelled out at last. So therefore, I'm giving you this question as homework. Try doing it, and you can comment your answer after the session. That's all we needed to do, guys. Don't forget to like and subscribe to the Infinity Learn Class 9 and 10 YouTube channel. And don't forget to subscribe to the Telegram channel as well, because whatever we discuss in the live sessions, this is not a live session, you get the PDF of those sessions. Bye-bye, guys. Take care, everybody. Thanks for watching.